The first demo is from Imagimob. It's a Swedish company, and the person is Sam Al-ATTIYAH. All right, let's enjoy.
Hi, today I'm going to talk to you about how you can use Imagimob AI to build models for the Texas Instruments radar. We're going to look at how you can use our integration with the radar to be able to collect better data to build better models and eventually show how these models could be applied in a real-life scenario. So first we're going to look at the data challenges and what's our actual solution to them. So the big questions that arise when you're looking at building a machine learning model is, how do I collect the data for this model? How do I actually annotate this data? And how do I get a better understanding of the data so I can build great models? So what we've done is that we've integrated these TI radars with our capture server. And what our capture server does is that it combines the signal data from any sensor with the video feedback. And that means that you can correlate these signals with what's actually happening in a real-life scenario. So in a normal case, when you're using audio and video data, you can obviously understand what's going on because they're correlated with our human senses. But then if you're talking about accelerometers or radars or temperature sensors, then it's very hard to understand how those actually relate to the real world. And that's the benefit of using this video feed. So next we're going to look at what it actually looks like. Here we can see the video that we've collected with the TI radar and how it's loaded using our tools. So we can see that we have the video signal, and that we can use to correlate it between what's happening with the data and to actually apply labels to this data. You also have some extra features like being able to play through the video, skipping through the labels, and being able to change the playback speed so that if you have something that's happening very quickly, you can actually have it running, the video running very slowly so that you can see exactly what happened, which can be very useful. So how do you actually get started? Well, you can download our tools and actually be able to get everything that you need directly from there. So it's just a matter of clicking the starter projects, and here we have a number of different ones. We have the human activity, which uses an accelerometer to detect what the human is doing. We have the Aquanier radar, which is also using gestures, and then we have the Texas Instruments radar. So you have two different options of how to proceed with the gestures using radars. And then we have a keyword spotter, which uses audio signals. And then we have an indoor-outdoor detector, which uses an environmental sensor. And so whenever you download any of these projects, you get the data, the actual model files, and some pre-trained models. So you're good to go. Or you can get the capture server integration so that you can collect more of your own data and make an even better model. So now let's look at my colleague Angelo, who's actually going to show this model in a real-life scenario where he's testing it in real time. So we are doing clockwise gestures and counterclockwise, and then left to right hand motion, and then right to left. And the idea is that it's more difficult to detect opposing gestures than ones that are completely independent of each other. And here we can see that the model responds with multiple outputs each time. So this you could use to even further improve it. And then one thing that's often neglected is actually being able to send random data to the model and have it not trigger. So it's easy to only focus on what you want to classify and have that in the statistics, but sometimes you want to also try to fool the model to get a better idea. So this is essentially what you can get with the Imagimob AI. You can download our tools and you can have some starter projects to get you going very quickly.
So So we actually have a few questions from the audience. So I will actually read that. So the first question is data labeling done manually or automatically? Can you answer?
So you can use tools to label the data manually. We also have some extra tools that allow you to do it automatically.
Okay.
But the main premise is to be able to label complicated data.
All right, so you have both methods. The second and third question is, what is the power consumption of TI Radar? And what is the Imagimob model size for this use case?
So that specific model, it was about 1.5 kilobytes of RAM, and I think about 5 kilobytes of flash. So it's a very small model, and the output files are pure C code. So there's you have the source code right there, and there's no extra code needed. In terms of power consumption, that's something that we are still working on to try to get the numbers, but we definitely think it's valuable.
Okay, so what's the model accuracy right now?
For that one, as you saw, it detected every single gesture performed without any false positives. So the actual numbers, it's in the 90s, but I don't have an exact one. But beyond that, we think that it's better to kind of look at it from how it performs in real life, and as you saw from that video.
All right, so how much data did you need to train this model?
So I think this one was about 40 minutes of data. It's kind of like a simple demonstrator. So it's trained on my colleague Angelo and tested on him. And the idea is that you can download the project and then you have everything that you need to actually collect your own data and further improve the model.
Okay, so actually I have a couple of questions too. I may miss the content there, but is there any specific reason why you actually try to use the radar as your sensor? And what's actually your main application targeting?
So let me start with the second question first. Our application is a development platform for being able to build the AI models in a very easy way for time series data. And we have worked with many different kinds of sensors, from electrical sensors like voltages and currents and powers to radars, to IMUs, so accelerometers and gyros. We've also worked with environmental sensors. We've also worked with the infrared heat camps and things like that. Our approach to it is that if you can get numbers out of what you have, you can build a model on it using our tools. And why we did it with a radar is that we see that nowadays there's a lot of applications where you would want to have a radar to perform gestures, and it works a bit better than having a camera, in the sense that you are not as blocked by objects. So another thing that we've done is that we've had a radar model with the in-ear earbuds, where you could where you could perform gestures, and these gestures can be performed through hats or hair and things like that, where a camera wouldn't really work.
All right, thank you very much. It was very nice video demo.
We especially want to give thanks to our strategic partners, which really helped us that we can make that event possible. So we have first our executive sponsors. We have ARM, which is the Software and Hardware Foundation for tinyML. Then at Impulse, tinyML for all developers. Qualcomm AI research, advancing AI research to make efficient AI ubiquitous. Sentient, end-to-end deep learning solutions for tinyML and Edge AI. And our platinum sponsors, Reality AI. They add advanced sensing to your product with Edge AI, tinyML. Then also we have Renaissance, broad and scalable edge computing portfolio. Our gold sponsors, Latent AI, adaptive AI for the intelligent edge. Maxim Integrated, enabling edge intelligence. Seed Studio, the IoT hardware enabler. SensiML builds smart IoT sensor devices from data. SynSense, building sensing and inference hardware for ultra low power embedded mobile and edge devices. And our silver sponsors, we have Aeon Devices, Deep Light, EMSA, Green Waves, Gravity Inc., HOTG, Imagimob, Geekzo, Rixon Technology, and SAP. So we really want to thank all of our strategic sponsors who help us. And I hope you all enjoyed it and that we see you again tomorrow. Good evening, everyone.